In this video, we are going to talk about Lambda expressions and a little bit about functional programming. So a Lambda expression is an anonymous method. So basically a method without a name, which is a little bit strange when you first hear about it. But what we can do is, following this syntax that we have here, we can basically write a pretty short method in a really compact way, which is kind of nice. So Lambda expressions have the following syntax. So the very first part is a comma separated list of parameters enclosed in parentheses. Okay, so this is kind of like the parameter list in a regular method, except usually that's at the end of the method header in the regular way that we were writing methods. With Lambda expressions, the parameters go at the very beginning. Okay, and the types of the parameters can be omitted. Okay, so you don't have to put the types like you normally do on the parameter list. And then if you only have one parameter, well, then you can completely omit the parentheses. So the parameters come first, okay, with these extra rules here. Then comes an arrow token, which is basically just a hyphen and then a greater than sign. And then a body, okay, so the body of the Lambda expression is like the body of the method. And that body has to either consist of a single expression or a statement block. So if the body consists of a single expression, then the expression is evaluated, and whatever that evaluates to, that's the return value. Okay. If the body uses statements, has a statement block, then you have to enclose the statement block in curly braces. All right. And then method calls do not have to be enclosed in curly braces. Okay. When you do that. All right. So let's take a look. All right, so here on this page we have 4 different examples of Lambda expressions. So here is the formal parameter list and then the arrow token. Notice here I only have one parameter, n. Okay. And so I don't put the type or anything else like that. Just the variable, the parameter, then the arrow token, and then here is an expression. Notice that expression in this case involves that parameter, which it normally does. Okay, so what would happen is that this is basically a very short way of writing a method. So you notice that's one of the benefits of Lambda expressions is that the length of the method is very short. Okay. Here I have another Lambda expression. All right, and so I have in this case 2 parameters, x and y. All right, and so therefore, since I have more than one parameter, I have to enclose the parameters in parentheses. Then the arrow token, and then on the right-hand side, I have an expression. That's a Boolean expression, right? X is greater than y. It uses the relational operator greater than. So the result of this will either be a true or false. Okay. So if you think about it, this is a very short method, way of writing the method with an if-then statement. If x is greater than y, then return true, else return false. So it takes that, which would be several lines in Java, and shortens it down into a very small expression. Right here is another Lambda expression. I have a single parameter z, then the arrow token. Here I have a method call, right? You notice I do not have to enclose that method call in curly braces. It's a statement, right? But I don't have to do that. I can just put it like this, and it will work just fine. All right, and then the last example I have here, I have a single parameter x, so no parentheses, and then I have the arrow token. And then here I'm using statements, right? I have some if statements, or if an if else if block, right? And so it has to be enclosed in curly braces. Okay. So here are 4 different examples of Lambda expressions. So um, what we're going to do is use these Lambda expressions to process lists and maps. So lists, such as an array list, can be processed using Lambda expressions. We can do the same thing with maps, and we can do that. The most basic way to do that is with these three methods: replaceAll, removeIf, and forEach. Okay. So these three methods in this kind of style of programming is something called functional programming, which involves the use of functions, calling functions as the primary way to evaluate or make computations. Okay. Some programming languages are purely functional. Java is not, and Java, this part wasn't added until Java 8. But you can see there are some benefits to this type of programming. So let's take a look at how to use these three methods here: replaceAll, removeIf, and forEach. All right, so the first one is the replaceAll method. And so with the replaceAll method, if you are given a list named list and a Lambda expression, Lambda, the statement list.replaceAll Lambda. So here you would have whatever the name of your list is, and then dot, and then replace all. And then inside the parentheses, you would put a Lambda expression. What that will do is call the Lambda expression once for every item in the list, and then it will store the result back in the list. Okay? Now remember, a Lambda expression is like a function, right? It's an anonymous function, and so when you call it, it's going to return a value, and so then that result that it returns is going to be stored back in the list, right, in place of what the input. Okay, so typically what you would do, what you would have to do in Java to do this without the replaceAll and a Lambda expression is to write a for loop, right, to go over the list and process it like that. Okay. One thing to be careful of here when you use replaceAll is that the value returned by the Lambda expression, it has to be the same type as whatever the type of the list is. So let's take a look at this replaceAll demo and see how it goes. All right, in the replaceAll demo, I create a list of numbers. And notice, right, I am using the interface, right? And that's something new. If you haven't watched the map videos, then that might seem a little strange to you that I'm using the interface name list as opposed to array lists, like you did in Java 1. So Java allows you to do this, and it makes your programming a little bit more flexible if you use the interface name here. You'll also see something else that I'm using right here, and it's basically a shortcut to create an array list. So here I'm using a method out of the list class itself, or the list interface, list.of, right? And then I am just passing the parameters, the elements of the array list to that method, and then putting that in the constructor for the array list. So that's possibly something that you haven't seen before. It's a nice shortcut for creating a list or array list of numbers. Okay. Next up, I just print that out. And here you can see how I use the replaceAll method. So I have the list nums that I just created, dot replaceAll, and then inside here I have a Lambda expression, right? That Lambda expression says n, right, maps to or evaluates to, however you want to say that, n divided by 2. So basically what this Lambda expression does, it takes whatever the input is and cuts it in half. And this is integer division, right? So it won't be exactly half, but it divides by 2 and then chops off the decimal point. All right, so I'm going to run this, and you're going to see the result of that. All right, so here's the original list that I had, right, that I created on line 7. And then line 12 I process with replaceAll, and then here in line 14 I'm printing it out. This is the result I get Okay, so you can see that every number in the list was cut in half basically, and well, of course, truncated, right? So 9, right? This evaluated this lambda expression to 4.5 and then chopped the decimal place off because this is integer division. And it replaced the 9 with the 4, right? -2, divided that by 2, got -1, and so on and so forth. So you can see that the result of this line, line 12, right, is that every number in the array list is replaced by itself integer divided by 2. Okay. All right, here I am going to, in line 16, create another list of strings in this case. All right, and so you can see I print out that list, and this is what I get: Alpha, Bravo, Charlie, Delta, Echo. And then here is another use of replaceAll. So that list is called words. I do words.replaceAll, and then inside I have a lambda expression, right? S maps to s.replace a with banana. So, and then plus s dot to uppercase plus s dot length. And so here you can see the results. Okay. So alpha, right, got mapped to banana alpha 5. Okay. So this lambda expression, right, takes the input and replaces all of the occurrences of A with the word banana, right, and then adds on the word uppercase, all uppercase, and then adds the length, right, onto the end as a string. All right, and then it replaces that element in the list, or replaceAll does that, right? So alpha was replaced by whatever was the result of whatever it was returned by the lambda expression. Same thing. So Bravo was replaced by this, Charlie replaced by this, and so on and so forth. Okay. All right. Next up, I've got an example using a map. All right. So here I create a map, and I print it out. All right. So you can see there's the original map that I have. All right, and then now I want to do replaceAll, and then here you can see I have two parameters, k comma v, and that's not a coincidence. K stands for key, right, and v stands for value. Okay. All right, so then I replace, or that key value pair, right, evaluates to 10 times the key length plus v. Okay. All right, so for instance, and you can see that the result of that replaceAll right here. All right, so the key value pair Bravo 2, right, gets replaced with 10 times the key dot length. So Bravo was 5 letters long, so that's 50 plus the value 2. So you can see it replaced the value with 52. All right, so now just think about, and it does that for each value, right? Alpha 1 would map to 10 times the length of alpha, which is 5. So 10 times 5 is 50, plus the previous value, so 51, and then updated. So if you think about back to the map section where we had to iterate over the key value pairs, right, this syntax is way cleaner, okay? Here, you can see it's very, very short for something like this. Okay, so that's the advantage, and one of the advantages of functional programming is that you have these shorter, nicer syntax to do some pretty powerful things with maps and lists. All right, next up is the removeIf method. So given a list named list and a lambda expression lambda, the statement list.removeIf and then lambda inside the parentheses, that will call the lambda expression. Remember, a lambda expression is a method function, right? So it will call it once for every item in the list, and then it will remove the item when the result of the lambda expression is true. So you can use this to filter lists and maps. All right. Let's take a look at that one. All right, so in this example, again, I create the same list that I did before and print it out. All right, and then I call, that list is called nums, right? And then I call nums.removeIf, and then the lambda inside the parentheses is n maps to n remainder 2 is equal to 0. Okay, so let's say 9. Okay, if I plug a 9 in for n, right, I get 9 maps to 9 remainder 2. Well, 9 remainder 2 is 1, right, because 2 goes into 9 4 times without going over, with 1 left over. So I'd get 1 equals 0, which is false, so the 9 is still there. With the negative 2, right, if negative 2 were plugged in for n, right, I get negative 2 remainder 2. Well, negative 2 is even, so 2 goes into negative 2, negative 1 time with 0 left over. And so I get 0 is equal to 0, which is true. So since, right, negative 2, when it was taken as input by the lambda expression, it returned a result of true, and so therefore that negative 2 was removed. All right, so if you look, right, the effect that this has is that it removes all of the even elements of the list. All right, and so again, if you think to how you normally do that, right, that's going to take a for loop, right? You would have to, get a for loop and then check each value and then do something else, right, in an if statement, right, inside there. So you can see that's super compact way to do that. All right, so next example is I create a list of strings, right, Alpha, Bravo, Charlie, Delta, Echo, right, and then print that out, right. Here's what I get. And then here is the example where I use removeIf, right? So words.removeIf, and then the lambda expression is s maps to s dot ends with a, right? So this will test if the string s ends with a. If it does, it will return true. If it doesn't, it will return false, right? So what's going to happen here is that all of the list elements that end with the letter A, in this case alpha and delta, right, when it evaluates the lambda expression for those list elements, it's going to return true, and removeIf is going to remove those. So you can see, right, the effect that that has is that it removes every element of the list that ends with the letter A. All right, so again, super compact way to do that. It's a one-liner now with this lambda expressions and this functional programming. All right, next up I have a map. All right, so I create the same map that I did in the previous example, and then I call removeIf, and then here, right, I am just using E for the entry set, right, and then I use e.getKey.length, all right, 2 times e.getValue minus 1. So that's a little bit different, right, than what I did in the previous example, just to kind of show you a couple of different ways to do that. So this is one of those map entry, right, and here I'm using the get key method to get the key and get value to get the value out. All right. So let's see, this get key.length is greater than 2 times e.getValue. So this is going to remove, right, all of the map entries where the length of the key is greater than 2 times the value minus 1. So that's kind of convoluted, but let's take a look at it. All right, so Bravo, we have the original map, we had Bravo 2 as a key value pair, right? So the length of the key, right, would be 5, right? Bravo has 5 letters in it. So 5 is greater than 2 times the value. So the value would be 2. So this would be 2 times 2 minus 1, or 3. So 5 is greater than 3, evaluates to true, right? And you can see, boom, that's been removed out of the list because that evaluates to true. Let's say for delta, right, the key would be, of the length of the key would be 4, right? So this would be 4. If 4 is greater than 2 times the value, 2 times the value would be 8 minus 1 would be 7. So for delta, the key value pair delta 4, we got 4 is greater than 7, which is false, right? And so that's why this one is still in the map, okay? All right, so there we can filter maps and filter lists using removeIf and these Lambda expressions to do it in a fairly short manner. All right, there are some special Lambda expressions called method references. And so those are easy to read Lambda expressions for methods that already have a name, okay? And so for instance, you might have a Lambda expression that looks like this: x maps to system.out.println x. You can write that as system.out and then 2 colons and then the name of the method like this. Okay, so that's a method reference. It's just an even more compact way of writing a Lambda expression. So there's 4 types of method references. If you have a reference to a static method, then you just put the class name and then 2 colons and then the name of the method after the 2 colons. All right. For a reference to a particular object, right, an instance method, so a non-static method, you would put the name of the object, right, that you want to call that contains the method, and 2 colons, and then the name of the method, like that. And then a reference to a method of an arbitrary object of a particular type, you would put the type's name, and then 2 colons, and then the method name itself. And finally, for a constructor, you would put the class name, then 2 colons, and then the new keyword here. All right, so you can even use constructors as these method references. All right, the final function that we're going to talk about in this section is the forEach method. In the forEach method, if you're given a list named list and a Lambda expression Lambda, then the statement list.forEach Lambda calls the Lambda expression once for every item in the list. And remember, a Lambda expression is a function, right? So it just calls the Lambda expression once, right? And for every item that you have in the list. So let's take a look at that. Okay, so here, right, and the first example, I have a list of student objects. So let's take a look at the student class. It's just your typical class, right? It has some fields for first name, last name, student ID, GPA. It has a constructor, right, that just sets the value of all the fields, and some get and set methods. Actually, just get and set for the GPA, that's it. And then a toString method, okay? All right, and so what I'm going to do then is here I create a list of student objects, just sort of using the old-fashioned way of doing it with .add method. All right, and here I am going to call the forEach method. So my list is named students, and then forEach, and so it will go through, and for everything in the list, it will call this method. And here you can see I'm using one of the method references. All right, so here you can see the result of that, right? This just prints out each of the elements in the list. So if you think about how we had to do that before, we had to use a for loop to do that, right? Now, right, with this functional programming style, we can just use the forEach method if we have them in a list. So that now becomes a one-liner. All right, next up is here I call the forEach method. In this case, I use just a regular Lambda expression, O for object, right? And then I call the setGPA method. All right, and then what I do is I get the GPA and add 1. So basically I increase everybody's GPA by 1. Okay, So, and then on line 16, I print that out. And so you can see, right, the result of that. Everybody's GPA was increased by 1. Right? All right, next up I have a map, and it's the same map I've been using in the other examples. And then here I am just printing out the key value pairs, right? So just print each of these things out, and you can see it just prints them out. The key value pairs, 1 per line here. Okay. All right, and so that is it on this one. And what we will do is look at some examples, but we will separate those out into their own videos.